Go.
Hello, my dear students. I want to quickly run through the quantitative aspects of two of your three assignments. I have, or will immediately after this, have another video ready for you, though I won't post it for another day or so, for the quantitative aspects of 10.3. If you haven't done the homework yet, hand it in. I'm giving you the answers, so if you haven't handed in by midnight tonight or when the due date was, which is noon tomorrow, I might take off 10 points. But other than that, keep working on your homework and do it. I'll give you some hints and clues and include a brief discussion of the material we're covering as we work these problems. So, in section 10.1, we introduce the mole, a quantity of matter which is equal to 6.022 times 10 to the 23rd represented particles. That could be atoms, it could be molecules, it could be molecules of a compound. So, in part D, this is to be graded separately from part A, B, and C, because it takes longer to do. We have 4 questions. Question number 15 asks, how many moles of lead is 9.3 times 10 to the 15th atoms of lead? That's a lot of atoms of lead. So the way we do this is we write what we know down. 9.3 times 10 to the 15th atoms is my unit, atoms of lead. And I want to get to number of moles. Now I can use a mole map, and if I did, it would tell you to divide by Avogadro's number. But I'm going to use dimensional analysis, and I'm going to multiply my number by 1. And in this case, my 1 is going to be 1 mole per 6.02 times 10 to the 23rd representative particles, in this case, atoms. So atoms are going to cancel, and my mole is going to be my units in the end. And so if you do the math, you will get 1.5, because I only have 2 significant figures there, so don't give me what I like to call calculator vomit. Your calculator may go and spin out a bunch of numbers, but only the first 2 are significant. 1.5 times 10 to the minus 8th mole. And that makes sense because I'm taking a very big number, but I'm dividing it by an even bigger number. And my warning to you is, if you're using a TI-84, and you should be, I would love to make some available to everybody, but I've got 70-some students, 79 students? I did have 79. I think we lost a couple. And I've lost the seniors, but I only have about 25. I have a classroom set plus a few more. So use the calculator on your phone. And I'm getting a signal, but I don't know what it means. What?
E on mole.
What?
Do you need an E on mole?
No.
No, okay.
Okay.
Sorry. I wrote it one way.
This is mole written out. This is the official abbreviation for mole. Why don't we use M? We don't use M because M's already used for meters. And MO, people I guess might confuse with molybdenum, the element, so the abbreviation for mole is mole. If I were to write this out, it would be moles, and that is my answer. And that makes sense because this is a very small number. But getting back to what I was saying, when you are putting these numbers in the calculator, there's a couple different ways to do it. You can use times 10 to the x, or you can use EE, exponents. And whatever way you do, put these numbers in parentheses, or the order of operations in your TI-84 will give you a nonsensical answer. So put this one in parentheses, and put this one in parentheses as you're doing your operations with your TI-84 to get the correct answer. So again, this is one of the problems we have. We work with very, very large numbers, and we work with very, very small numbers like our answer. And there's your answer. I'll have some more to say about these as we go along. So the next one says, what is the mass of ethane? But they give you the formula for ethane. It's C2H6. And they want the molar mass of ethane, and there's one way to find it, and that is those red numbers up on the periodic table that corresponded to some made-up unit that is called an atomic mass unit, which 1 is equal to 1/12 the mass of an atom of carbon-12, and even that's not totally true and precise anymore because we've refined our measurements and have greater precision now. But here's what they really equal. How many grams there are in a mole of that element. So carbon is element number 6. It has an atomic mass of 12. And there are 2 of them. So carbon is 12 grams per mole. Okay? And there's 2 of them. And that would be 24 grams per mole in ethane, because there's 2 of them in ethane. And hydrogen is equal to 1 gram per mole. I know you can go there and you can say 12.0017 for carbon, and you can say 1.00, I forget what it is, 172 or something for hydrogen. But we're just going to call it 1, and there's 6 of those. So in every mole of ethane, there are 6 grams of hydrogen per mole of ethane. And the total atomic mass of this element is the sum of the masses of all of the atoms in it. So the mass of ethane is 30 grams per mole, and that's your answer. I hope that wasn't too hard. So, freeze the tape, do what you need to do. But I am going to erase that and grab one of my kitchen paper towels and erase these 2 problems and put the next 2 up, and we'll be done with this, and we'll quickly do the next one, though it requires also a little exposition and discussion by me. The next 2 finds the mass of K2SO4, which is potassium sulfate. So this is 16, nope, this one would be now be 17. And K2SO4 has 2 potassiums, 1 sulfur, and 4 oxygen. Okay? So, potassium is 39.0983 grams per mole. So 2 of them would give me 78.1966. And sulfur is equal to 32.065 grams per mole. And one of them would give me 32.065. And oxygen is equal to 15.99916 grams per mole. And 4 of them, 4 times 16 would be 64, but with greater precision it would be 63.996 grams per mole. And so I add these up to get my molecular weight of potassium sulfate. K2SO4 has a molecular weight of 171.2576. And I can say it with that precision because we know these masses to that precision. And so, we have next, it asks, find the mass of 3.65 times 10 to the minus 2 mole of potassium sulfate, and I just multiply it by 1 times 171.2576 grams per mole. Okay? And so my moles cancel, and I'm left with grams. And if I multiply 171.2576 grams by 0.0365, I will get an answer of 6.36 grams. Okay? Now, if you want to leave that in scientific notation, obviously it would be 6.36 times 10 to the 0, because any number raised to the 0 power is equal to 1. But that's how many grams, this many moles of this compound would weigh. The thing we needed to calculate was the molar mass, or the molecular weight, or the molecular mass of this compound, the formula mass, since it's technically an ionic compound. So that would require that we go look up in our periodic tables the atomic masses for the average atomic masses for the different elements and sum them, because we had 2 potassiums, 1 sulfur, and 4 oxygens. So that was the only trick to this question. Now the last question for this assignment is, how many representative particles in 2.5 moles of H2O2? So we really don't need to know anything about hydrogen peroxide. All we need to know is that we have 2.5 mole, abbreviated MOL, and to convert from moles to number of particles, represented particles, in this case molecules, of hydrogen peroxide, H2O2, we need to multiply it by Avogadro's number. So Avogadro's number states that there's 6.022 times 10 to the 23rd representative particles or molecules, individual units of H2O2, molecules, per mole, per 1 mole, per 1.000 mole, per 1 mole. So my moles will cancel, and this will give me an answer of a number bigger than that, because I'm multiplying Avogadro's number times 2.5, and I get 1.5 times 10 to the 25th representative particles or molecules in this case. You can use whatever unit you want or molecules there. So this is how we work those problems. There'll be a couple problems like this on the test. Don't panic. The test will be what? Online and open book. So if you just look at how I did these, and I use a different element or a different compound, you just follow the same process and substituting the new data that I'm going to give you. I might ask you how much in 3.5 moles. You know, something just to change it up a little bit. So that's it for section 10.1. Thank you, and I will see you in the next video.